Alright, ladies and gentlemen, this video is a follow-on to our last class in which we voted and decided to work on creating a to-do app as a way of exercising our newly developing UML skills. So your assignment 1 is to write a Java program using UML practices, which means that you're going to design the UML diagrams first, and that is going to inform how you put together your code, and that is reflected in item number 3 of our grading rubric, which is good object-oriented design, right? And I've shared another link with you there as well from another class I teach, which is some basic Java programming principles. But basically what we're looking for now is that we conceptualize, we use UML to vision what our application is supposed to do. And there's several kinds of UML diagrams we're going to cover: class interaction diagram, object interaction diagram, activity diagram, right? And they all share the commonality that they give us a way to create graphical notational representations on a design tool like Visio or on a piece of paper. And then by moving the elements of those notations around, then we get some insight into what the code is going to do when we start writing it. Now, if you like, you could use Visio or something to do your UML diagrams. I personally just like to draw on paper, and then I can take a picture and upload it to my presentation document, because the thing I don't like about these computerized tools is you spend too much time playing with the computer, and it detracts your mental energy from where you should be, which is thinking how your good design goes. All right, so let's go over here to our piece of paper now, and let's carry on. So I'm just going to leave some stuff here on the paper because it's kind of windy where I am. I don't want my papers to blow away. But the way I like to do it now is you can go to a bookstore or a dollar shop or something and buy these cards, like these notational cards, 3x5 inch index cards. And then I draw my diagrams on here, and then it's easy to move them around and change around my design. So my concept now, or my goal, is to make a grocery app, which is pretty similar to your to-do app. I just didn't want to show you the exact code, but this will be quite transferable. So now the first question I asked myself is, what are all of the topics, right? And I think you guys have had relational database as well. So you know that when we design a relational database, we start by making tables for all the topics or elements of our business domain. So what are all the things which must be part of my grocery list app domain? Well, I need the list itself. I need some data structure. To contain my items. And I'm actually doing this a bit more complicated than you would probably really need to do it, because we're going to make a second object now, which is the message, which in the case of your to-do app, the message will be the to-do item that you need to take care of. And here our message is going to be our grocery item, right? Our thing that we need to buy at the store. Right, so that's going to be a Java object, of course, and this is going to be a Java object, probably an array list or something, I guess, some sort of a Java collection, which is going to hold on to a collection of these classes. So this is going to be a class, which is my grocery list. And I'm going to have a grocery item. Do I need anything else in my grocery list app? Well, I don't know what your guys' shopping is like, but when I go shopping, I often have to go to several stores because maybe one store sells a certain product in a particularly good way. So I might want to contain where's the store that I'm going to go to. But now I start asking questions as a UML designer, and I think about appropriate assignment of responsibility. Right, that's the basis of UML. In fact, that's actually the purpose of all of your 5 different kinds of UML diagrams. You figure out into which item should you park each data attribute or each behavior, right? Because we know that in Java, a class can have what 2 kinds of things? Well, it can have data attributes and methods. It can have 2 attributes, data attributes and methods, and we model them in our UML entities. And then appropriate assignment of responsibility is the question we're thinking about when we contemplate which data item or which method should be assigned to which container, the container being the Java class or the UML entity. So if I have several different stores I could go to, does the store that I'm buying from deserve to be its own separate entity, or would it be an element of something else, like maybe the item that I'm buying? And there's no one right answer to any of these things, and the purpose of UML is it lets us play around with this stuff before we start writing code. But I know that my grocery item is going to be the message, the unit of value I'm moving around in my app, and I'm going to want to organize things by list. I'm going to choose in this case to make my store to be its own item. Why? Because what kind of things might I want to put in the store? Well, maybe it's location, right? Maybe I'll hook that up with a mobile app with a GPS coordinate or something, so I can have a mapping app. And then, as I write my items, I would note which store they're in, right? So what am I going to have in my grocery list? Well, we'll call it grocery item. It could be food, could be something else, laundry detergent or something. And it might have a price, I guess, so I can plan my shopping budget. It might have a location, so that's my location there. But the location is just going to be an address. So now that I stop and think about this, I realize as soon as I try to make this Java class, I actually don't really have very much to put there. So in my current, I'm going to put this aside for right now because I don't think it's worth having the location as a separate object. However, I might change my mind on that later. Or now I'm asking maybe the item name would belong over here, and maybe the price would belong over here, not here. And when we teach first level Java, the biggest challenge we find with students is identifying how to model things in the real world, which is what we're doing when we write a Java class. So it's which behaviors and which data do you put in each item. All right, so my list is going to consist now of a grocery item, right? So that's that, and that carries all that information with it, and a location. And should I put the location in here? And I think no, because I'm thinking about usability, and I'm thinking that the item might be available in several different stores, and I might want to abstract that information out to a higher level so I can move that around when I'm planning my shopping. So far this looks pretty good. I have the item name, the price. Do I need anything else? Probably. When I'm writing my code, by the way, I might think of other things I need here, because as we saw in our PowerPoints, when you're writing an application, there are 3 domains in which you're working, right? So you have the analysis, which we're doing now, which we do with UML. And then we have the design. Sorry, analysis is done with use cases, which we're not really doing use cases here. This is not a business analysis class. And to be honest, our algorithms are pretty simple. But if we were investigating the operation of more complicated business processes and algorithms, we might, in that case, need to do use cases, but not now. We do our design with UML, and that could be your data schema, right, your database, as well as your Java objects as we're doing here. And then finally, our third phase is the implementation, where we write the Java code and we design the database. And as you go forward, this is called forward engineering. So you go from your UML to your Java objects. And as you're writing your Java objects, you might find things that looked good in design, but they don't really work that well in Java because of the nature of the Java language. There might be better ways to do it. So then we would reverse back to here, right? So we change our design based on how things work in our implementation. And this is called round trip engineering. And maybe you've seen ads, job ads saying they want programmer analysts with familiarity with round trip engineering. Well, now you know what that means. So let's go back to our design. How am I making out so far? Well, I have a list which is probably going to be an array list, I suppose in Java, some Java util collection object. And I have my item, which is also going to be an object. And that should do it. So my design is pretty simple here. Now, the two kinds of UML diagrams I'd like you to work with in this app, and you may want to play with other ones, right? I'll give you a link to some of my other material. But this is going to become a Java class, and this is going to become a Java class, and these are going to communicate by method calls. And the way we coordinate our method calls is with something called an object interaction diagram. And once again, this is a deliberately very simple business domain. So it's sort of like crushing a peanut with a sledgehammer to apply all this UML analysis here, but it probably makes more sense to apply it to a simple case before we apply it to something very complicated later on. So an object, now you've seen a class interaction diagram, right? This is a class interaction diagram. We have a grocery item here. Another benefit of UML is it lets you plan out the names you're going to call things by before you start writing your classes. And then if you sort of make a mistake there, it gets kind of messed up. It can be a lot of trouble to go and fix it later. So as we know, there are two ways, and this is questions for your upcoming test as well. Well, I think you already know this, although you already know this anyway. Two ways to connect Java classes. We can do method calls between them, and we can do field composition. So the fact that I have a grocery item here, which is actually a class, that's the name, but this is the entire class. So this is a field composition of these two classes. I'm composing a collection. This is a collection object. But I'm composing a collection of grocery items into a data structure by making that field to be a field type grocery item. Right, and once again, this is such a simple problem, we don't really have too much else to model here. But I'm now going to show you how we can write this up as Java. And then the other thing I want to show you is an object interaction diagram. And once again, it might be kind of a stretch to figure out how to get an object interaction diagram into a very simple application. Well, just do your best. Now, the title of our course is Software Development and Maintenance. And you can understand, or maybe you've had the experience, you've worked in a company which when they're developing a new product, everybody is excited, right? They're thinking about it 24 hours a day, and they're really familiar with the code domain. But then time passes, they move on to another project and another project and another project, and then 8 months later you have to come back and change your project from here. And now you've been thinking about so many other things, right? There's a joke in IT, but it's a joke that tells the truth. They said, when I was writing this code, only God and I knew what I was doing. Now only God knows. You'll look at your own code and you won't really remember it if it's anything of any real-world complexity. So diagramming like this is not just to design it now. It is for you or maybe other people on the team when they have to come back and support the code later on. So let's make a simple example. So now you've seen a class interaction diagram, right? That's a class interaction diagram because it shows how classes are connected together by field composition. Right? It visualizes how classes are joined, or the data plumbing works, or connected, or data plumbed together. by shared field composition. When I show you the code in a minute, you'll see that more. Now the other, well, there's actually 5 types of UML diagrams, but the 2 I use the most myself when I'm writing real applications is the CID, the class interaction diagram, because I want to most efficiently connect together my classes using fields. And the other thing is, how do the classes talk to each other, or maybe even how does a class call services within its own self via method calls. So we have an object interaction diagram which shows you the sequence. It's also used for what's called method choreography. Which shows you the sequencing. Method sequencing is another name by it. So let's say I have a class now, and that's class A, and class A has method 1. And class A might also have method 2. And then we might have class B, and that might have method 1, and class C may also have a method. So the purpose of this diagram now, I draw a lifeline under each method, and then I draw the connection. So here, class A might connect to class B. We know how it works, right? What's the only way class A can ever get a signal over to class B? It will invoke well, 2 ways. It can invoke an instance of class B and then call an instance, a method instance reference, or method 1 here might be a static, and then it can do a static call on method 1 from class B. If you're not totally sure what I'm saying, I'll show you some code in a couple of seconds here. But for right now, and we also know something else. We know that everything that happens in Java, the code must be contained in a method. So I have a method going on here, because if I didn't have a method, it wouldn't be doing anything. And from that method, I call class B method 1. Maybe as a static call, or maybe I instantiated an object to class B and it's an instance call. And what can a method have? It can pass in parameters, right? So it can pass some parameters on the method signature, and it can also get back a return value. So class A in this case is calling method 1 on class B. It's passing in some parameters which are available in the execution context of class A. And then class B is returning to the execution context of method 1 class A. It's returning some value. So that is an object interaction diagram. A couple of good benefits of it. Number 1, we can plan the sequence, right? What should come before what? And we can figure out before we start writing one single line of code for our algorithm to work, what parameters do we need to pass and what value are we getting back? So I'm now going to write the code, right? I'm just going to pause the video for a couple of seconds. I'll come back with some fully functioning code. We'll talk through it, and then we will do this. We will do some round-trip engineering, right? So we've done our analysis, which we all know what a grocery list looks like, so we didn't need to write use cases. But we now made some UML. We're going to do some code, and then we might reverse back from our code. We might make some changes to our UML. So go and get yourself a cup of coffee. I'll be back in a minute. But don't go too far, because a minute literally means a few seconds in video land. All right, guys, so you're going to do the to-do app. I did the grocery list app, which is quite simple, and the purpose isn't to be an amazing piece of Java code, because we know you know how to code Java. The point now is to learn how to not only write code, but how to design it, and design it in a way that it can be maintainable. So following standard practices, I have one class, which is the application controller. that is outside of my business objects, which are running my app, right? And his only job is to just kick the soccer ball and get the program up and going, right? By the way, I'm giving you all this code over here. It is going to be in a jar file. You know what a jar file is, right? Java archive resource file is just basically a zip file that we can store Java archives in. So maybe like the JUnit framework or something, you get the jar file, and then that will contain all of your Java classes. So you can open and close and work with jar files with WinZip, just like you would any other zip files. It's a standard file format. All right, so anyway, there's the code that I'm working with, and that's available if you want to see it. So anyway, he's going off now and calling grocery list, which is in a class called grocery list. And again, following standard practices, I'm factoring out, right? So I have a grocery item, which is an ADT, which is a message class that makes an object that stores details about one grocery item. And then here I have my collection, which I'm actually running in a array list, which is available here because I'm importing java.util.collection. So this class is holding on to all of my grocery items. Now, the way I like to do it is the command and control pattern. So I only ever call one method from outside, which is the run method, and then I do all of my method choreography inside run. Just makes it easier, right? When you're the manager at work, mandate your team to follow this practice, because then if one team member is on vacation or something and somebody else has to jump in and take over for their supporting their code, they'll all know how each other is working. So here we have add grocery item, print the list, and then calculate the total. So let's run that to see what it looks like. So here in Eclipse, my console is showing up in this window. So maybe you want to buy some bread. And bread is $2, or maybe $2.07 or something. And then we want to buy some oranges. Maybe a dozen oranges is like $5.12 or something. And then we want to buy some carrots. Now, how do I get out of this? The way I'm doing this is extremely simplistic. Of course, if this were a real program, I would not be doing it this way. I would be using Java FX, the GUI framework, and I'd get drop-down lists and all that stuff. However, the purpose of this is not Java. The purpose of this is to see how the UML design language connects with Java. So what I did it here, just to keep it fast and simple, is a for loop. So in my add grocery items, I'm just saying while true, not a for loop, but a while loop. So it's just looping around until I enter the text exit. And then I'm forcing that to lowercase, so whether that's upper or lower, it'll still work. So when I enter exit, then my program would return. Of course, if I wanted to buy something called exit, like exit apple juice or something, I guess that wouldn't work. But good enough to illustrate the concept right now. So let's type exit over here to get out of this. And now it's giving me a summary of my list. Bread, oranges, carrots, and the total price. And once again, I could use Java formatting. I'm not going to spend time on that right now. But that's just to remind you if you kind of need a little brushing up on a basic Java program. But again, the real focus right now you should be concentrating on is making some UML, right? So you want to see some method interaction, method choreography. Like that program is pretty simple, but it does have enough methods flowing around that it's going to give you something to work with. And it also does have, enough there you can make a class interaction diagram because you do have two objects. I mean, you have the controller object, which is getting the guy up and running. I generally don't model that because there's two kinds of things we have here in Java. We have business objects and we have structural objects. The business objects are doing the stuff that we find interesting. The structural objects are just sort of things we put there to make the application work, right? I just like to have one application which is outside of my business logic to park public static void main into. Anyway, it's your assignment. You do your best. Send me an email when you need help. But again, you're just going to write your code similar to mine or different, just so long as you get some sort of a note-taking app up and going, substantially similar to what I've done, except you're going to be adding notes instead of grocery items. And if you're really ambitious, you can maybe try writing a search function. So if you want to print out all the notes that contain a certain text string, such as, I don't know, go shopping or something, you can print them out. You don't have to. It's not a Java assignment, but if you want to stretch your Java, you could. But once you've written your code, I want you to go based on the methods I showed you in the first half of the video. I would like to see a class interaction diagram emphasizing or visualizing the field composition between your classes, and also object interaction showing the method calls between your classes. Any questions, give me a call. See you later. Bye.